Hi, so this is my team, me, Hariprashanth Pengonda and Venkata Bhaskara Tetali. So today we are going to discuss about our project hate speech detection. So now I'm going through the introduction of the project. So let me open my PPT. Yeah. So the rise of online, so the rise of online social networks has facilitated global communication, but also increased the spread of hate speech. So this project aims to develop a system capable of detecting hate speech using machine learning techniques. So the primary objective is to enhance social media moderation and improve your safety by identifying and preventing the posting of offensive content. So we have used a methodology. So you can see here, our project aims to detect the hate speech and try to not post the hate speech, any hate content in the social media. So the first social media application, a user uses the social media application. So if our model detects any hate speech in that post, so if it does not allow the user to post that post in the social media. So now we will go through the methodology. So the data set used in this project was sourced from Kaggle, so containing labeled samples of hate speech and offensive language. So data processing involved several steps. So converting text to lowercase and removing punctuations, numbers, emojis, and all other things. So we have handled every contradictions. So we have used visualization techniques such as word clouds were employed and to analyze the data distribution and to gain insights into the prevalence of hate speech terms. Okay. So next I will walk through the model selection and validation. So in this model, we have used a logistic regression model was chosen for its simplicity and also for its interpretability in binary tasks. Although logistic regression is straightforward, it may not capture the nuanced patterns of hate speech due to its linear nature. So the model was implemented using Python libraries like NumPy, Pandas, Scikit, and Streamlit. So the valuation metrics included confusion matrix, included classification reports and accuracy scores, access model performance. These were used to access the model performance. Next, I will walk you through the system architecture. So the system architecture is designed for its efficiency and accuracy. So following a sequential flow from data input to audio inputs through au- automatic speech to text conversion for audio data. So the architecture comprises three main components. So what the three main components are pre-processing layer, model prediction layer, and response layer. So the results. So when we have done this model, we have got some results. Like the model achieved an overall accuracy of 91% across 9,914 samples, but showed uneven performance across different classes. It excelled in detecting explicit hate detection with high precision and recall, but struggled with more subtle expressions, indicating a bias towards majority classes. So in the discussion part, like we have the empirical analysis reveals both strengths and challenges. The model effectively identifies explicit hate speech but faces difficulties with contextual understanding, such as sarcasm or cultural references. Evasion techniques like converting text to images or using coded language pose in additional challenges. So in future directions, let me go through the performance metrics. So this is the performance metrics table that we got while running the code. And let me show you this while running my code. And the future directions. In this future research, we will focus on enhancing model architecture with transform-based approaches like BERT or GPT to better capture linguistic nonsense. Multimodal analysis capabilities will be developed to handle various media formats simultaneously. So in future, we would like to develop a voice recognized based system, and we would like to check this with a video. So if any unofficial videos or any he- videos that are not able to post in social media, so that we can check whether those videos are good to post in social media or not. So these are the future enhancements. But for this project, we have done only like the text-based hate speech detection. So in the conclusion, so the project successfully developed this a machine learning based system for detecting the hate speech in text and audio inputs, contributing to safer online environments by preventing offensive content posting. So the future address will be as I have said the previous, we will work on the voice based system, and we will work on the videos also. Okay, so that's all for that. Thank you. Now, this role is for the methodology. Sorry, empirical analyst role. Now my teammate Bhaskar will continue the methodology critic purpose perspection of the role. Thank you.
Hi, my name is Venkata Bhaskara. Going to the introduction. The pro Next slide. Yeah. The project utilizes logistic regression for classification, chosen for its interpretability. However, this choice presents several limitations. The dataset is highly imbalanced with 7,677 samples in the majority class and only 596 in the minority class. This imbalance is reflected in performance metrics with F1 scores ranging from 0.35 to 0.94 depending on the class. Such disparity indicates significant sampling bias, questioning the model's real world applicability and critical analysis. Uh, Logistic regression's linear nature may not capture the complex patterns inherent in hate speech, which often involves subtle and contextual language nuances. Basic pre-processing techniques are employed, but they lack advanced features that could better model than complexities. Next slide. And the choice of logistic regression raises methodological concerns. Limited complexity. The model simplicity may not suffice for nuanced hate speech detection. Absence of cross validation. The lack of k-fold cross validation, questioning that model's generability. Feature engineering. Standard preprocessing may not capture semantic relationships and contextual nuances effectively. And for the collaborative process reflection, next slide. Yeah, and the methodology reflects limited collaborative input. A single model approach suggests minimal exploration of alternatives. Comprehensive validation methods are absent, indicating potential gaps in peer review. Iterative improvements and decision making processes are poorly documented. Next slide. Yeah, recommendations for improvement. To address these limitations, several improvements are suggested. Data imbalance mitigation, advanced feature engineering, model architecture enhancing, and robust validation framework, which is implementing k-fold cross-validation and exhausting fairness, evaluating across demographic groups. Next slide. Yeah, future research directions. Future research should focus on developing context-aware classification systems that adapt to changing language patterns, privacy preservation methods, and robust adversarial defenses should be investigated to enhance system applicability. Next slide. Collaborating framework enhancement. A structural collaborative framework is essential for improving methodology. Regular methodology reviews and clear documentation of decision-making process should be incorporated. An error analysis framework is crucial for continuous improvement, including detailed error categorization to understand misclassifications. Next slide. Multilingual and cross-cultural considerations. The methodology should address multilingual and cross-cultural aspects explicitly. Strategies for cross-lingual transfer learning and cultural specific hate speech patterns are necessary to handle diverse language context effectively. Next slide. Technical infrastructure and scalability. In this, scalability is crucial when dealing with real-time social media streams. The methodology should consider computational requirements and optimization strategies for large-scale data preprocessing. Efficient GPU utilization and parallel processing support are vital for maintaining real-time performance at scale. Next slide. Ethical framework and governance. A, a comprehensive ethical approach is necessary for balance effective content moderation with individual privacy rights and ensure transparency in decision making process and provide robust appeals mechanism for context review. Uh, Last slide. Yeah. Thank you.
So now let me walk you through my, let me run my code and show you the outputs. So this is the hate speech detection code. Let me run my code. So here, this is just in developing mode. Like I have been doing this in the future enhancements also. Like I have been trying it in the attaching it to cloud, and I have been doing the voice translation also. But now I have completed only the hate speech detection by using the text format. So you can see we have downloaded the necessary packages that we need, and the data set I have took from the Kaggle is hate speech.csv. So here we have seen the raw data where you can find posts, some of the posts that contain the hate speech. So by this hate speech, we have using the data processing. So I have cleaned the data, and I have done the data pre-processing. After that, we have seen some class imbalance. So let me show you the yeah. After running all the classes, this asks for the text input. So if I give any hate input, like let me give you some bad words, like when you give any let me- oh sorry. So yeah, first this asks for an input, like this is I'm just developed this code for the text format. So this so now it when I press one, it goes into the text mode. So I thought to develop when I choose my choice as to it asks for the voice or a video, like in that way. Now only I have developed for the text mode, so this asks for the text choice. So now I will need to give a word that contains a hate. So this have detected the offensive language detected 88%, the so probability for hate speech decision. So this is the code that we have developed. Thank you.